there, it's Shannon Matchick-Myers coming at you live from Carlsbad today in beautiful northern San Diego. So we will be covering inferential statistics, and some of the basics about inferential statistics are that you need to understand the difference between what you do for populations as far as, illustrating data, organizing data, and all that for populations. We don't need to make inferences about a population if you're using population data because you know everything about that population. So what we use is just our descriptive statistics, and that's all we need. But when we have samples, what we usually do, because it's cheaper and or easier, usually a combination of both, is we use samples to make inferences about populations. Okay, so to do that and to describe things about samples, we use both the descriptive statistics, which is what our last unit was about, and statistical analysis. And within the statistical analysis, we're going to be making predictions about paired data, and we make inferences about central tendency and or spread. And probability comes into play when we're dealing with this analysis. So study design is also important. We will get into more details as we go on, but we've got observational studies where obviously you record your information. You don't impose a treatment, all right? So you just gather your sample subjects and then you just observe them and you record the results. So for example, if you want to see if there's some correlation between smoking and lung cancer, you're not going to have somebody trapped in a room smoking for 10 years and then record data about whether they get lung cancer. That wouldn't be very ethical, right? But experimental is recording the information, often pre and post treatment, right? So if you want to see if some sort of blood pressure medication is effective, you will collect data on their blood pressure before and after the treatment. And then often you use blind or double-blind experimental design, and blind means that the subject doesn't know if they get the treatment or the placebo. Placebo is just, they think they're getting a treatment, but they're not. And the double-blind means that the actual scientist or researcher doesn't know if the subject is getting the treatment or the placebo. All right? So, tools needed. Probability will play a huge part, and we use parameters. You're going to use Z, which you've had some experience with, and we'll also use T as a parameter. There's other things out there, but that's what's coming up soon. And then, so this looks a little scary. This is actually the standard normal distribution, meaning that it has a mean of 0 and a standard deviation of 1. So that's what we were working with at the end of the last section, and this is what it looks like. So this whole region here underneath the curve sums to 1, and that is true about all probability distributions. So we'll be learning all about that as we go forward, but I just wanted to give you a heads up as to what we were going to be covering. All right, so I hope you have a great day, and I'll talk to you soon. Bye-bye.